Let's start off with the properties of definite integration. So the first one is very logical, where you have a to b fx dx is equal to minus b to a fx dx. So it's just logical that if your limits are 1 to 2 and you find the value of the integral, and if the limits you change it from 2 to 1, so obviously the sign will differ of the final answer. So because of these properties, it makes a definite integration more interesting to solve than indefinite. So this was the first property, okay, can be used in sums. The second one is wherein you just change the variable. So what happens is, in definite integration you get a definite answer. So the variable doesn't matter. So if I find a to be fx dx, or if I find a to be ft dt, the answer will be same, okay, because the variable has changed, but the answer will be same. The third one is, if you have a case wherein there is A and there is C and there is B. These are three numbers, and C lies between A and B. So you can split the integral. So if you have A to B fx dx, this can be written as A to C fx dx plus C to B fx dx. You will usually find this property widely used in sums which have modulus. So in modulus or in GIF functions, you use this property. And the fourth one you have is a to b fx dx is equal to a 0 to a f of a minus x dx. So the answer will be same in both the cases. This is more widely used, when you have functions like sine cos, sec cosec, tan cot, functions which can form complementary formulas, like sine of 90 minus theta is cos theta, right? Something like that. Okay, so let's start off with few questions which are based on these properties, and let's go through them. So let's start off with the first one. So let's say we have the question as 0 to pi by 2, and you have root of sine x upon root of sine x plus root of cos x dx. So let's start off with the solution. So sine and cos. So and the property which I'll use is property number 4. So I'll use property number 4, and that would be 0 to pi by 2 root of sine. So the property was a minus x. So a in this case is 90. So I'll write sine of 90 minus x upon root of sine 90 minus x. So wherever you have x, you will just replace it by 90 minus x, because 90 is your a. Okay, so this was the start of the question, which is I, and let's see what we get now. So after doing this, what we get is, we use complementary angle formula. So sine of 90 minus theta is cos theta. Then you have sine of 90 minus theta, which is again cos theta. Cos of 90 minus theta, which is sine theta dx. So now this is, let's say, 2, and this is 1. You add 1 and 2, you get 2i, I plus I, which is 2i, and you get 0 to pi by 2, and you get root of sine x plus root of cos x upon the common denominator, root of sine x plus root of cos x dx. And this gets cancelled, so you have integration of 1. Integration of 1 is x, so you get x 0 to pi by 2, which is equal to pi by 2, but this is equal to 2i, so I will be equal to pi by 4. So very simple question, and this sum can come, instead of sine and cos, they could have written cosec and sec, or they could have written tan and cot. The answer would have been the same. Okay, let's try another one. So let's say the next one is, so the question is, we are finding minus 2 to 1 mod of x dx. Okay, now if we understand modulus x, so modulus x will be uh, different in different intervals. So we know mod x is equal to x when x is greater than equal to 0, and mod x is minus x when x is less than 0. So what I'll do is I'll write minus 2 to 0, because that will give me the mod x as minus x. Okay, so I'll write mod x as minus x for that portion because x is less than 0, and for 0 to 1 I'll write mod x as x. Now we'll integrate, so we have minus x square by 2, and you put the values minus 2 to 0 plus x square by 2, 0 to 1. And now when you put the limits, you get so either is minus sign 0 minus 4 by 2 plus 1 by 2 minus 0. So what you get is 2 plus 1 by 2. So the answer is 5 by 2. So this was one of the lectures of the properties of definite integral. In the coming lectures, we'll check some more properties of definite integration. Till that time, take care. Bye bye.